So we had a lot of requests for demonstrations. We wanted to come out here today, here in Jackson, Mississippi, and film an unedited demonstration of the Sentaro v2VTOL with both a gimballed EOIR payload and a standard 42 megapixel Sony A7R3. Today it's going to be operated out of SEI's Mobile Operations Center. We'll do a quick walk around of kind of what that entails, and then we'll get into assembling the aircraft, going through the checklist, and then ultimately into the mission. So all we've done so far is unhatch the trailer, get some stuff set up, take the aircraft out of the case. Comes in two cases, this one and that one. Wings and tails in one, fuse in the other, with GCS stuff kind of in both. All the foam's custom cut, allowing for that sort of workflow. Just two cases. Everything's got locks, wheels, all that kind of stuff. So transport's relatively simple, and the cases themselves aren't that large. So again, we'll get into a little bit about the MOC, and then we'll swing around to the side, show the communications mast, and kind of what all that houses. So.
Yep.
So Nathan, if you can, just go ahead and talk about what is housed on this mast. This is a 15-footer, so it's not up all its whole 15 feet because we don't need it. But they can either be 15 feet, 30 feet, or 60 feet depending on the terrain that you're operating in.
Yeah, so this is a Skyhopper. It's our C1 link. Operates on a 2.4 gigahertz band. And you can see we've got the tether. This is kind of our umbilical cord that's running into our MOC. We've got our RS-232 connection, our network cable, and our power run through here and into the MOC, and eventually into the server rack where it interfaces with Mission Planner.
Okay, so we'll swing in, we'll show the MOC super quick. So a lot of what's housed in here is going to be relatively standard no matter your operation. Retractable storage space that houses, you know, it could charge batteries while it's there. Storage, couple chairs here, a 4-monitor display, and then all the power's in the back. So it's a generator box with a control panel, as well as a battery reserve. So also climate control, both heating and cooling. It's not on right now because we don't need it. It's a pretty nice day out. That also extends the life of your power supply, not having to run that climate control.
Yep.
So if I didn't miss anything.
No, and we're going to be operating from one of the two server racks that are installed in this MOC. The other server rack will be powered off and used later in a different flight.
Okay, so we'll get into assembling the aircraft.
Okay.
Nathan, just kind of go ahead and get everything.
So we normally install the wings first. We have two wings with these quick connect clips. The motor booms connect like that, and then if you see, we have this connector here. It interfaces with the wing and works really well. We just slide it in, and when it gets a real good snap, you'll actually feel these clips. They stand up pretty tall, and then that's how you know that it's in there. Cody, can you provide some support while I attach the other wing?
Two things to note with the way this aircraft's assembled: you don't have to mess with two things: wiring and tooling to assemble the aircraft. You see how it just snaps in and gets its power that way.
So this wing is slightly different from the other wing. It has the pitot tube installed in the wing itself. So airspeed sensor, and it provides all the information through the wing on the left wing. And when you hear the clicks, that works. You can make sure that they are fully seated. Okay, so that's working. Next, we will attach the VTOL. Two sections. When we're working, we're just checking to make sure that the control rods and horns are good. It's just a little easier to do that now while you're assembling it than later when you have to reach under the aircraft. Okay, same thing with this. When it clicks in place, you know it's there, and we'll just tug to make sure that they're fully seated. And that's the that is the end of the assembly process.
That's assembly.
Okay.
Let me get this case out of the way for you.
Thanks.
All right, so what's the next step, Nathan?
Next step, once the wings and tails are in place, we'll go ahead and install the battery. And we have our main power here, battery power there. We'll just keep those nice and handy. We have Velcro straps inside, and you just want to make sure that they don't get bunched up and underneath the battery, so they just come over the top of the battery, strap it in. Okay, so we have the checklist. We have two checklists. We have the main checklist, and then we have an emergency procedures checklist. We'll be operating from this checklist. Every time we fly, we use this checklist, and there's basically several steps here, and it's front and back. So Cody and I are going to work together on this. I'm going to get my headset on, and we're going to utilize the call and response method for that. Check, check, check. Okay, gotcha. All right, so what's the first step?
First step is checking the motor booms, make sure they're locked and latched in place.
Okay, motor booms are locked and latched in place, and they are secure.
Wings attached securely.
The wings are attached securely.
The tails are attached securely.
The tails are attached securely.
All right, motors attached, freely spinning.
They're attached and spinning freely. At this step, we're just looking for anything that feels different, any grinding, any loose feeling. They're secure, so we'll move on to the next step.
Props are attached securely.
They are attached securely on the front and on the back.
And the control surfaces are secure.
We'll just lightly tug on the control surfaces to make sure they're secure. We do this in the process when we're setting up before we assemble, but it's a good practice to do it after it's assembled too. Just lightly tug on the control surfaces and verify that there are no cracks in the hinge.
And the payload's installed.
Payload is installed.
All right, we'll go batteries installed but not plugged in.
Battery is installed, but it's not plugged in.
All right, we'll CG check with the motors forward.
Okay, I'm going to do that now. So I'm going to go ahead and strap this down just in place where I think it should be, where the battery I think it should be. If we need to adjust the battery, the CG, the battery can move forward or aft as necessary. So I'm going to put the propellers, the motors down, and check the CG. Okay, and the CG is checked. It's about a centimeter behind the standard CG. This payload is a little bit heavier, and this aircraft is configured a little differently. So the CG that on certain aircraft, other configurations of this aircraft is about a centimeter forward, and this aircraft configuration is a little bit back. So the CG has been checked, and it's fine.
All right, the controller is Q Stabilized and on.
Okay, so I'll get the Spectrum transmitter. We're utilizing a 900 megahertz transmitter. We're going to power it on, and it is in Q Stabilize.
All right, and the laptop is on.
Our GCS computer is on. You can go to the telemetry computer and continue from there.
All right, so we'll go. Telemetry is plugged in.
It is.
Open. Plane is open. Plane is on.
Okay, let me turn the plane on now. So with the telemetry radio plugged in and turned on, and the computer and the mission planner launched, we will then move on to the next step, which is powering the aircraft on. Once the aircraft finishes booting up, we will connect to mission planner. Okay, next step.
All right, next.
Okay. Okay, good. So mission planner is connecting to the aircraft. It's going to be basically it's downloading the parameters just like any Pixhawk based flight controller. It's doing that process and we're just waiting for it to complete it. Once all those parameters are downloaded, we'll move on to the next step, which is looking at the telemetry computer and make sure that it's getting information from the aircraft fed directly to the telemetry.
All right, we are fully connected.
Okay, let's move on to the next step then.
All right, radio link.
Okay, so what's the percentage of the radio link in the HUD?
Radio links are
99. Okay, 99%.
show 99.
Okay. And then next step.
Or 96. All right, next step is HUD, no errors.
Okay, do we have any errors on the HUD?
We do not.
Okay, good.
All right, headings within 20 degrees, no headings.
Okay, so Censys gives us a compass. We're going to use that to determine the heading of the aircraft and compare it to what it's actually showing. So I know that north is generally in this direction, east is behind me. So I'm going to put this in on the aircraft and then point this to north and then get a reading. Now granted, you got to be careful because you can get some interference if you're around certain things, but over the battery you should be okay. So north is this way. I'm showing about 092 or 095. What do you have on the telemetry computer? You don't have the HUD. Is the HUD showing that? Okay.
Let's display.
Good. So 96. He's getting 96 on the telemetry. So I'm showing around 95, maybe 92 to 95 on here. You could use your phone to do the same thing. You just need to know that it could be a little off. So I like to use two sources. We know from a previous experience that that's pretty close. That is within 20 degrees of known heading, so we'll move on to the next step.
We'll go to GPS and just click and check the on the map. We have reading
Okay. GPS checks, and we have good GPS signal, so we'll move on to the next.
All right, ground speed, airspeed.
Okay.
Our ground speed and altitude is 0.
Okay, ground speed and airspeed. Or ground speed and altitude.
Yeah, they're both close to 0.
Okay.
Alright, so we'll go servos armed.
Okay, we'll arm the servos now by removing this plug. Basically interrupts power to the servos. We're going to remove it and you'll hear the servos move. Okay.
Alright, payload checking on.
Okay. It appears to be on. The fans are spinning.
Alright. Payload lens cap if it has one.
Okay, not applicable. Moved on.
Hatch cover is in place and secure.
Okay, the hatch cover is in place. This one is, and that one is. So all hatch covers are in place and secure.
Alright, check Q stabilization, picture on.
Okay. So we're going to check the Q stabilization, make sure that it's working properly. So I'm going to basically roll the aircraft to the right and verify. And you can see that it fights the movement. And verify that that's working on the HUD. Okay, pitch up. Okay. Okay, so that's working. So we've got telemetry's working. Okay, move on to the next step.
Alright, check the controls and Q stabilize.
Okay, so now that we've checked the Q stabilization is working, we're going to control using our C2 controller and make sure that we have control of the control surfaces. Okay, we have control of the aircraft and Q stabilize.
Alright, auto switch, push forward to off.
It is off.
Alright, and check fly-by-wire stabilization.
Okay,
Control y'all.
switch into FBWA mode, fly-by-wire. This is forward flight mode, and we're going to check Q stabilization in FBWA. We'll do the same thing. We'll tilt up, pitch up, and it fights the movement. We're going to right wing down, and it fights the movement. Left wing down, it fights the movement. And that works. Now we'll do our controls checks, make sure that's going to work properly. So left aileron, left wing goes down, right wing goes up. Same thing with elevator. All controls are working in FDWA.
Check both front motors tilt forward to the same degree.
Both motors tilted to the same degree.
Alright, and going to see